Assalamualaikum and hi students. Let's continue our lesson with tutorial question chapter 2 with second hour materials. Okay, let's start to discuss non-face-to-face question first. Non-face-to-face question. Okay, question number 1. A 1.0 gram sample of aluminium and 1.0 gram of iron are heated from 40 degrees Celsius to 100 degrees Celsius. Which metal has absorbed a greater amount of heat? Alright, so you have two different metals. Alright, okay, let's start with aluminium. So initially, 1.0 gram aluminium, right? So the mass is 1.0 gram. Okay, initially the temperature was 40 degree Celsius. Alright, so initial temperature is 40 degree Celsius, and this metal, metal was heated, and the temperature rose to 100 degree Celsius. So when the metal absorb heat, of course, it will absorb some amount of heat. And you are going to calculate the heat absorbed by aluminium first, right? Okay, so how to calculate the heat absorbed by aluminium? So we have this relationship. Heat absorbed by aluminium is equals to mass of aluminium, alright, times specific heat capacity of aluminium times delta T. Alright. Okay, so you have the mass. You have the mass of aluminium. Okay, so you may substitute the value. Okay, so we have 1.0 gram aluminium. The specific heat capacity of aluminium was given in the question, right? So this is the value of specific heat capacity of aluminium, which is 0.900 joule per gram per degree Celsius. And from the information, initial and final temperature, you may find the delta T, where delta T is 60 degree Celsius. So when you calculate, the heat absorbed by aluminium is, alright, 54 joule. Alright. Okay, now let's continue with iron. Okay, iron ataupun simbol dia Fe lah. Okay, so the mass of iron also 1.0 gram. The initial temperature also 40 degrees Celsius, and final temperature is 100 degrees Celsius. Okay, so iron after heated, okay, iron will absorb some amount of heat. So to calculate the heat absorbed by the iron metal, Q iron is equal to mass of iron, right, times specific heat capacity of iron times delta T. Semua information telah diberikan. Termasuklah specific heat capacity of iron diberikan di sini. Okay, substitute all the values. Okay, we have 1.0 gram. Okay, and the specific heat capacity of iron is 0.444 joule per gram per degree Celsius times 60 degree Celsius. So you will get 26.64 joule. Okay, by referring to the heat absorbed, okay, heat absorbed by aluminium and heat absorbed by iron. Okay, kita kena rujuk dua nilai yang kita kira ni tadi. Okay, kita akan dapat lihat di sini. Okay, we can see here which metal absorb more heat. Okay, jadi kalau kita lihat kat sini, the question ask you, suruh pilih. Okay, jadi kita akan pilih lah. Alright, and please write your answer. Alright, so we can say here, aluminium metal absorb. Okay, aluminium metal absorbed more heat. Okay, more heat compared to iron. So kita tak boleh tinggalkan jawapan dengan kita kira sahaja. Kita kena, lepas kira kita kena pilih. So pilih, beritahu dalam jawapan awak. So you have to write this statement. Okay, so this is question number 1, non-face-to-face question. Okay, so now let's move to question number 2, non-face-to-face. Alright. we have this problem. In a calorimetry study, powdered xylose, so this is xylose chemical formula, combusted in a bomb calorimeter. The following data was obtained. So we have these data. All right. First, you have to define the heat of combustion. Right. Okay. So you can see here from the statement, xylose is completely combusted in a bomb calorimeter. Jadi, kita nak define dulu what is heat of combustion ataupun enthalpy of combustion. Okay, so the answer is heat release when 1 mole of a substance completely combusted in oxygen gas. Okay, mesti ini sahaja jawapannya. So, kalau salah tulis, memang salah. Okay, substance. Right? Okay, next. Calculate, okay, kita settle ni. Calculate the heat of combustion of xylose in kilojoule per mole. So please be careful. We are going to determine the heat of combustion of xylose. Ataupun kita nak cari enthalpy. In other words, we are going to determine the enthalpy of combustion of the substance. Siapa substance tu? Xylose. Okay. In kilojoule per mole. Maksudnya apa? We are going to calculate how many heat is released. Kenapa release? In terms of definition, kita tahu combustion, heat of combustion adalah heat release. So, how many heat release when 1 mole of xylose is completely combusted in oxygen gas? Okay, so kita kena fahamkan dulu apa yang berlaku dalam eksperimen ini. So, kita kena fahamkan apa yang berlaku dalam bom calorimeter tu. So here I have a diagram that shows the cross section of bomb calorimeter. Jadi kita gambarkan kat sini, kita masukkan xylose tu di sini. The substance that we are going to burn iaitu xylose tu kita masukkan dalam bekas inilah. So this is the sample. Sample cup dalam tu ada xylose. So ini kita punya bahan yang kita nak bakar, xylose. Okay? Okay, so now you can see here, in the bomb calorimeter, we have thermometer to observe the temperature changes. Kita nak observe perubahan temperature. Mana dapat, you tengok kat sini data tu dah ada. We have initial temperature and we have final temperature. Okay, the bomb calorimeter mempunyai specific heat capacity. Maksudnya bomb calorimeter ni dia ada specific heat capacity masing-masing. So it was given in the question. Alright, telah diberikan dalam soalan. Okay, bagaimana combustion berlaku? So, the sample is ignited electrically and the heat produced by the combustion reaction can be calculated accurately by recording the rise in temperature of the water. Maksudnya bila kita nyalakan, kita ignite, okay, sampel ini, kita lakukan pembakaran tu, maksudnya kita ignite dia secara electrically. So, the heat produced by the combustion reaction, maksudnya bahan dalam bomb calorimeter ni akan terbakar. So, dia akan terbakar and what happen? The heat released from the combustion reaction, okay, will be absorbed by the water and the calorimeter. So, ini semua ini adalah kita punya sistem. Kita dah belajar kan sistem. Okay, jadi kita nak observe, kita nak ukur tu macam mana dengan melihat, okay, kita boleh calculate the heat release accurately by recording the rise in temperature of the water. So the heat given off by the xylose is absorbed by the water and the bomb calorimeter. Okay, so basic principle, okay, kalau kita ingat balik dia punya konsep asas, bagaimana bomb calorimeter itu bekerja. Sepatutnya from the reaction kita dapat heat release, okay, heat release by the reaction. Boleh juga ataupun saya tulis specifically by the combustion reaction equals to heat absorbed by by the water and calorie meter. Betul? Okay, so kita anggap sistem ini adalah isolated. So maksudnya heat of the system includes apa? Heat from the reaction, heat from the water, absorbed by water, and heat absorbed by the calorimeter. Therefore, it is equal to 0. Since it is isolated system, no heat enters or leave the system. Therefore, heat of the reaction supposed to be equals to heat absorbed by water and heat absorbed by the calorimeter. Ini konsep asas yang you kena tulis sepatutnya. Okey, ataupun you kena fahamkan terlebih dahulu. Okey. Jadi, kalau kita lihat kat sini kan, okey, basically, okay, saya contohin dekat atas Basically, kalau kita nak kira heat of water, tak ada masalah. Heat of water equals to mass of water times specific heat capacity of water times delta T. Okey, kalau kita nak kira heat absorbed by the calorimeter sama dengan apa? Heat capacity of calorimeter times delta T. Okey, delta T tak ada masalah sebab kita dapat daripada data. Dalam data ada. Okey. Heat capacity of the calorimeter ada. Kat dalam data pun ada. Specific heat capacity of water pun ada. Kita tahulah ataupun rujuk pada senarai constant. Okay, the issue here is mass of water. If you refer to the experimental data here, we don't have any, did not mention, tidak dinyatakan dalam soalan, the mass of water. Yang ada kat sini mass of xylose. Okay, sedangkan air adalah a part of the system in the calorimeter. So macam mana kita nak selesaikan isu ini kalau kita tak ada mass of water? If we don't have mass of water given in the question, macam mana kita nak selesaikan? Sebab kalau ikut prinsip asas yang kita belajar, disebabkan bom calorimeter tu ada water kan. So heat released by the combustion reaction of xylose equals to the heat absorbed by water and the calorimeter. Tapi sekarang mass of water tu tak ada, macam mana kita nak kira heat of water? Okay, actually, jangan risau. You tengok dekat sini. Actually, dalam nota awak ada. Okay, some books, some international book, include water as part of the calorimeter. Ada setengah buku international ni, dia anggap air tu ataupun mengambil kira water tu adalah sebahagian daripada calorimeter. So, bila assumption ini ataupun anggapan ini ataupun dia mengambil kira perkara ini, maksudnya air itu adalah sebahagian daripada part of the calorimeter, the value of heat capacity of calorimeter include that of water. Maksudnya capacity of calorimeter tu telah termasuk air sekali. Jadi, macam mana kita nak berbalik kepada soalan kita ni tadi? Macam mana nak kira mass of Q water kalau mass of water tak ada? Sebenarnya inilah dia punya penyelesaian. So, kita boleh gunakan Q reaction dalam kes ini equals to negative Q calorimeter. Jadi macam mana kita nak tahu kalau mass of water is not mentioned, kita boleh terus guna ini sahaja sebab heat capacity of calorimeter tu telah termasuk juga water. So in this case, what happen? Kita boleh tulis macam ni lah. Kita boleh tulis, heat, release, by the combustion reaction, saya buat short form, equals to heat absorbed, heat absorbed by the calorimeter. So how we are going to calculate? It is equals to, here is Q reaction, equals to negative Q calorimeter. Kenapa ada negatif kat depan? Sebab saya dah ajar ni tadi. Firstly, kita anggap dia isolated system lah. Susun balik. Alright. Okay. So now, let's continue with the calculation. Okay. So, how we are going to solve the problems? So, in order to calculate, to determine the heat absorbed by the calorimeter, it is equals to, this is the formula kan, heat capacity of calorimeter, heat capacity of the calorimeter times delta T. So the heat capacity of the calorimeter is, so this is for question number 2. Saya terlupa nak tulis. Is negative, right? Negative 4.728 kilojoule per degree Celsius. Alright, times the delta T. So, daripada data ini, saya nak awak tekan kalkulator kira delta T. Okey, kirakan delta T. Kalau nak kira terus kat dalam ni pun boleh jugalah. Maksudnya you kena tunjuk kat sini apa dia. 27 final temperature. 27.19 degree Celsius minus initial temperature. 23.29 degree Celsius. Okay. So now the heat released by the calorimeter, the heat released by the reaction, the heat released by the reaction is, negative 18.44 kilojoule. Because you can see here, the unit per degree Celsius and Celsius cancel out, right? Okay. So now, apa yang kita kira ni sekarang? Yang kita kira ni sekarang adalah heat released by the reaction. Heat released by the reaction ni maksudnya yang berlaku in the calorimeter. Maksudnya berapa banyak you burn Xylose tu tadi. You sebenarnya masukkan dalam calorimeter tu 1.183 gram. So bila 1.183 gram ini burn in the calorimeter, dia release sebanyak ini. Negatif 18.44 kilojoule. Okay, ni saya dekatkan sikit lah negatif ni kerana dia tak perasan. Okay, dia release sebanyak negatif 18.44 kilojoule. Bila masa 18.44 kilojoule ini release, bila 1.183 gram Xylose burnt, in the calorimeter. But the question asks you to determine the heat of combustion of Xylose in kilojoule per mole. Okay, heat of combustion ataupun enthalpy of combustion is heat release when 1 mole of Xylose is burned in oxygen gas. Okay, so now kalau 1 mole Xylose burn, berapa banyak yang akan release? Itu isunya kita kena kira. Okay, so pengiraan ini tak habis lagi. We have to continue. Okay, so you have to continue with number of moles of Xylose. So cari mole of Xylose. Tunjukkan jalan kerja. So we have 1.183 gram. Okay, divide by 150 gram per mole. Okay, so you have to use your calculator carefully. So you will get around 7.887 times 10 to the power of negative 3 mole. So, by using stoichiometrically relationship and the Q reaction tadi, maksudnya kita dapat tu tadi Q reaction is negative 18.44 kilojoule, right? Okay, so saya dah sebut negatif 18.44 kilojoule ini adalah heat release apabila 1.183 gram Xylose terbakar. 1.183 gram Xylose ini bersamaan dengan berapa mol? 7.887 darab 10 kuasa negatif 3 mol. So kita buat statement stoichiometrical relationship. Okay, 7.887 times 10 to the power of negative 3 mole Xylose. Okay, tak nak tulis nak macam ni, tulis formula pun boleh, chemical formula dia. Okay, burn releases. Okay, how much? Okay, negative 18.44 kilojoule. Saya bawa je negatif tu. Okay, actually kalau dah dia tulis release ni tak ada negatif pun tak apa, tapi saya bawa je. Okay, therefore if 1 mole of Xylose burn, okay, releases berapa banyak? So you have to calculate. So how we are going to calculate? So 18, okay, negative 18.44 kilojoule. So this one is released by 7.887 times 10 to the power of negative 3 mole, okay, times 1 mole of Xylose. Okay, so you can see here 1 mole cancel out. Okay, tak apa, cancel out dulu. Jangan risau kat situ. Okay, maksudnya sekarang yang saya nak cari adalah kalau 1 mole Xylose burn kan. Okay, you selesaikan, you akan dapat berapa? You akan dapat negative 2338 lebih kurang 0.025 kilojoule. Tapi you kena faham, ini negatif 2338.025 kilojoule ni adalah heat release when 1 mole of Xylose burn. So we are going to calculate the enthalpy of combustion of xylose in kilojoule per mole, right? So final answer is negative 2338.025 kilojoule per mole. So this is the answer, final answer with the correct unit. Okay. So you kena tunjukkanlah perkaitan ini. Okay, tunjukkan jalan kerja dan inilah dia. Mole kena cari. Okay. And now the third question pada soalan ini dia minta thermochemical equation. So kalau you refer kat sini kita dah settle number 1, number 2. So dia minta thermochemical equation for the combustion of xylose. Okay, ingat kalau thermochemical equation kita kena tunjukkan delta H di hujung itu. So, for question number 3, the thermochemical equation, okay, macam mana kita nak tulis thermochemical equation ni? You tengok soalan number 2 tadi, since kita kira enthalpy of combustion and the unit is kilojoule per mole, in kilojoule per mole, maksudnya kita kena tuliskan thermochemical equation itu, the combustion of xylose, xylose tu mesti 1 mole pada equation. So, please check your answer. Suppose the thermochemical equation is C5, okay, H10 O. Okey, kalau dia beri tahu Xylose tu apa, boleh letak face dia. Okay, if you refer to the question, it is powdered. Powdered tu maksudnya solid. Okay, so here is solid. Alright, okay, plus, okay, oxygen gas. Plus oxygen gas produces carbon dioxide and water. Carbon dioxide gas and water. Okey, tapi disebabkan water liquid tapi disebabkan di hujung ni kita nak letak enthalpy of combustion. Okay, because this is the enthalpy of combustion, heat release when 1 mole of xylose burn tu tadi. Okay, so saya tulis sekali lagi dia punya enthalpy here at the end of the equation. Enthalpy of combustion is negative 2338.025 kilojoule per mole. So, make sure xylose. Yang mana xylose? This one is xylose. Xylose is 1 mole. So, here is 5 mole of oxygen gas and 5 mole of carbon dioxide followed by 5 mole of water. Okay. 5 mole of water. Alright. So, semua ni betul baru kita panggil dia thermochemical equation. Alright, so this is for question number 2, non-face-to-face question. Okay, so continue with face-to-face question for second hour. Alright, so this is a question. The combustion of naphthalene. Okay, the combustion of naphthalene can be used to calibrate the capacity of a bomb calorie meter. The heat of combustion of naphthalene is 5132.8 kilojoule per mole. Okay, when 0.8 to 10 gram naphthalene was combusted in a calorimeter containing 1000 gram. Okay, so we have the mass of naphthalene, we have the mass of water in the calorimeter. A temperature rises, okay, of 4.21 degrees Celsius was observed. Okay, determine the heat capacity of the bomb calorie meter. Okay, so by referring to this cross section diagram for bomb calorimeter, maksudnya apa yang kita masukkan dalam calorimeter ini, kita masukkan di sini kita punya naphthalene. So naphthalene is C10H8. Okay, and then di luar seal bomb ini, maksudnya di luar bekas yang kita letak sampel naphthalene tu ada water. So ini adalah water. Water kita kat sini berapa gram? 1000 gram. 1000 gram. Okay, alright. So berapa banyak naphthalene yang kita masukkan? Kita masukkan naphthalene kat dalam ni 0.821. Okay, sekejap 0.8210 gram. Okay, so the important information given in the question here is, if 1 mole of naphthalene burn, dia akan release banyak ini. Okay, macam mana saya tahu release? Sebab ini adalah combustion reaction. So memang kena tahu definition lah. Okay, but the question asks you to determine the heat capacity. The heat capacity of the bomb calorimeter. Berapakah heat capacity of the bomb calorimeter? Jadinya sekarang, apa maklumat? What information that we have? We have the mass of naphthalene. And then dia ada kaitan dengan mole, amount. Maksudnya amount tu dalam unit, dalam mole lah kan. So first of all, actually we can determine the mole of naphthalene. You cari dulu mole of naphthalene. Mole of naphthalene is equals to, alright, 0.8210 gram divide by the molar mass. So the molar mass of naphthalene is 128.0 gram per mole. So when you calculate the mole, you will get around 6.414 times 10 to the power of negative 3 mole. Okay, so this is the mole of naphthalene yang kita masukkan dalam bomb calorimeter itu. Okay, so now if you refer to the question, we have heat of combustion of naphthalene, which is 5132.8 kilojoule per mole. So actually this one is enthalpy of combustion. Okay, enthalpy of combustion. Jadi, seelok-eloknya you convert this statement dalam bentuk thermochemical equation. Okay, so kita tukarkan dalam bentuk thermochemical equation. So, siapa yang kena 1 mole? Sepatutnya dah tahu dah. Naphthalene tu yang kena 1 mole kan? Okay, so we have naphthalene C10H8. So, which is in solid state. Alright. Naphthalene reacts with oxygen gas. Okay, produces carbon dioxide and water. So, water boleh tulis sebagai water vapor ataupun water liquid lah. Sebab kalau dia jadi vapor pun, lepas tu dia akan jadi liquid. Okay, so bila you tengok kat sini, the value of delta H given, enthalpy of combustion ini ada per mole. Jadi, bila kita pindahkan dalam bentuk thermochemical equation, dekat sini kan kita kena letak apa? Enthalpy of combustion. Negatif. Kenapa negatif? Sebab combustion reaction. Negatif 5132.8 kilojoule per mole. Okay, sekejap saya kecilkan sikit. Okay, kilojoule per mole. Okay, kita tambahkan unit. Alright, so kilojoule per mole here. Don't forget kilojoule per mole. Tapi tak balance lagi equation. So, kita kena balancekan equation ini and make sure the naphthalene is 1 mole. Okay, the naphthalene is 1 mole. Jadi, bila kita balancekan, you akan dapati kat sini 12, okay, 10 and 4. Okay, so, kita tak boleh nak kira Q reaction sebab kita tahu kalau berapa yang terbakar dalam kita punya bomb calorimeter ni adalah 0.8210 gram. So 0.8210 gram ni bersamaan dengan berapa mol? Ini dalam bentuk mol lah. Okey, jadi maksudnya yang berlaku dalam calorimeter ni, maksudnya heat release in the calorimeter ni, which is absorbed by the water and calorimeter itu adalah Q reaction. So, how we are going to calculate the Q reaction? So, Q reaction equals to negative. Okay, kita ada apa kat sini? Kita ada water because heat will be absorbed by water and the calorimeter, right? And the calorimeter itself. Jadi, cuma seelok-eloknya kita tulis macam ni dulu. Sebelum kita tulis formula, better you tulis dia punya konsep. Heat, okay, heat release. Okay, heat release. Okay, by the reaction. Okay, by the reaction equals to heat absorbed. Okay, equals to heat absorbed. Okay, by apa? By water and calorimeter. Okay, Jadi, kalau kita lihat kat sini, apakah formulanya? Actually, this one is Q reaction equals to negative Q water plus Q calorimeter. Okey, tapi kalau you tengok di sini, okay, saya naik ke atas sikit Okey, kita nak kira Q water, mesti ada apa? Mass of water, specific heat capacity of water times delta T. Kita nak kira heat absorbed by the calorimeter sama dengan apa? Heat capacity of calorimeter times delta T. Tapi soalan minta heat capacity of the calorimeter ni. Ni yang kita tak tahu. Jadi, kita tak boleh kira directly Q reaction tu dengan formula ini sebab ada salah satu maklumat kita tak tahu. We don't know one of the information which is heat capacity of the calorimeter. So, apa yang kita tahu, apa yang ada dalam soalan adalah the enthalpy values. Enthalpy values ini shows that 1 mole of naphthalene burn, it release heat sebanyak ini. So, kita gunakan perkaitan stoichiometry. Okay, so 1 mole naphthalene, alright, naphthalene NPHTA ataupun C10H8 tu lah, boleh je. Okay, 1 mole naphthalene burn releases. Berapa banyak? Letaklah negatif. Negatif 5132.8 kilojoule. Tak payah letak per mole dulu sebab saya dah menyatakan kat sini for 1 mole. Okay. Therefore, kalau yang kita masukkan dalam bomb calorimeter tu tadi 0.8210 gram which is equivalent to atau equals to 6.414 times 10 to the power of negative 3 mole naphthalene. So, if this amount of naphthalene burn, how many heat release? So you kena kira lah. Maksudnya apa kat sini? 6.414 times 10 to the power of negative 3. Okay. Mole. Okay, naphthalene. Okay. Alright. So, kita tengok kat sini. Kita nak cari for 1 mole. So, that's why kita kena cancel mole. Divide by 1 mole of naphthalene. So, 1 mole of naphthalene releases this amount of heat. Negative 5132.8 kilojoule. So, cancel out. You akan dapat satu amount. Berapa banyak? Negative 32.922 kilojoule. So, apa maksud negative 32.922 kilojoule? So, actually, this is the Q reaction. Heat release from the combustion reaction in the calorimeter. So, kita dah dapat Q reaction kat sini. Alright? Okay, so how we are going to continue the calculation? So, tadi kita dah gunakan kaitan ini kan? Ini you tulis dulu, ini sangat penting. Okay, memang kena tulis konsep ini. Alright, and then we will continue the calculation. Okay, the calculation, you masukkan dalam formula Q reaction, where the Q reaction, okay, equals to negative sum of heat absorbed by water plus heat absorbed by the calorimeter. Okay, so apa yang kita ada kat sini? We have negative, kita baru kira tadi, negative 32.922 kilojoule kan? So this one you have to convert to joule first. Sebab apa? Sebab nanti kita nak gunakan specific heat capacity tu ada unit joule. So convert kepada joule. So here is negative 32922 joule. Okay, equals to negative. Alright, okay. Macam mana kita nak kira heat capacity of, heat absorbed by water? Ini adalah mass water, specific heat capacity of water, delta T. Plus heat capacity of water times delta T. Delta T tak ada masalah sebab dia dah beri dalam soalan. 4.21 is delta T. Okay, so masukkan lagi sekali negative 32.922 joule. Equals to negative. So here we have 1000 gram times 4.18 joule. Okay, joule per gram per degree Celsius times 4.21 degrees Celsius plus heat capacity of the calorimeter which is unknown. Okay, which is unknown. Nanti saya letak kurungan dululah. Times 4.21 degree Celsius. Okay, solve. So, you will get the heat capacity of the calorimeter sepatutnya lebih kurang 3640. The unit must be correct. Joule per degree Celsius. Joule per degree. Sorry, ya betul. Joule per degree Celsius. Okay, because gram dengan per gram ni dah cancel out. Alright? Okay. So, must give the correct answer with the correct unit, class? Okay. So, ini sebenarnya soalan face to face number 1, Okay. So, last question for face to face second hour. Okay. We have the combustion of 0.1326 gram aluminium. Okay, so bila combustion dia mesti gunakan bomb calorimeter, or other terms is constant volume bomb calorimeter. Okay, with the heat capacity given 1410 joule per degree Celsius. The bomb calorimeter was surrounded by 800 gram of water. Okay, ada 800 gram of water di sini. The temperature of bomb calorimeter was and water increased by bertambah sebanyak 1.726 degree Celsius. So, this is the delta T. So, the question asks you to calculate the heat of combustion of aluminium in kilojoule per mole. So, maksudnya kita nak cari enthalpy of combustion of aluminium, and final answer mesti unit dia kilojoule per mole. Okay, kita analyse dulu. Saya gunakan gambar rajah bomb calorimeter. So, apa kita masukkan dalam bomb calorimeter ini? Sampel kita lah. Apa dia? 0.1326 gram aluminium. Okay. So, di luar seal bomb ni, maksudnya di luar bekas yang ada sampel kita tu, it is surrounded by water. So, water kat sini berapa banyak? Berapa gram? So, actually dia masukkan 800 ml. So, 800 ml bersamaan dengan 800 gram. Alright. Okay. So, when the combustion occurred, ataupun during the combustion reaction, so what happened? The temperature increase. Okay. The temperature of the bomb calorimeter and water, maksudnya temperature of water tu juga bertambah sebanyak, okay, given to you already, the delta T 1.726 degree Celsius. Okay, calculate the heat of combustion of aluminium. Jadi, sekarang ni, kalau saya nak tuliskan dia punya thermochemical equation with unknown delta H, dengan delta H yang saya tak tahu, saya boleh tulis sebenarnya. Saya boleh tulis macam ni. Combustion of 1 mole aluminium in the bomb calorimeter, okay, alright, will produce, apa dia? Will produce aluminium oxide, solid. So, delta H ataupun enthalpy of combustion is unknown. Saya tak tahu sekarang ni. Jadi maksudnya, since the unit of heat of combustion is in kilojoule per mole, maksudnya aluminium kita ni mesti 1 mole. So, you have to balance the equation. We have 3/4 mole of oxygen here and half mole of aluminium oxide. Okay, so equation ini kena tulis dululah. Okay, with unknown delta H. Okay, so what happened in the calorimeter? The reaction will release some amount of heat. So, tulis heat release. Okay, heat release by the reaction. Okay, equals to heat absorbed by water and calorimeter. So this concept, the basic concept, basic principle of the calorimeter ni kita kena tulis. Tulis dulu. Alright? Okay. Kalau kita terjemahkan dalam bentuk equation or formula, macam mana? It is equals to Q reaction equals to negative Q water plus Q calorimeter kan? Jadi, nampaklah kat sini. Kita berdasarkan maklumat yang kita ada tu, kita nak kira apa. So, you have the, okay, saya gunakan pen hijau. You have the mass of aluminium. You have the mass of water. So, bila kita ada mass of water, kita tahu specific heat capacity of water, we can calculate the heat absorbed by water. Okay, kita tahu dia punya heat capacity of the calorimeter, kita boleh kira heat absorbed by the calorimeter untuk cari Q reaction. Okay, so let's continue. Okay, so first of all, we are going to calculate the heat released by the reaction. So, bawa formula tu tadi, which is equals to, alright, okay, Q water plus Q calorie meter. Okay, Q water nak kira asing-asing pun boleh. Nak kira masukkan dalam formula ni pun tak ada masalah. Yang penting berhati-hati. So, it is equals to what? Mass of water times specific heat capacity of water times delta T. Okay, plus heat capacity of calorimeter. Okay, sorry. Heat capacity of calorimeter. Okay, times delta T. Okay, so we have all the informations for water. Okay, jadi kalau you masukkan kat sini, kita masukkan sajalah equals to negative, okay, 800 gram. 800 gram times 4.18 joule per gram per degree Celsius times delta T. Delta T was given here. Okay, 1.726 degree Celsius plus specific heat capacity of heat capacity of the calorimeter is 1410 joule per degree Celsius, alright, times 1.726 degree Celsius. Okay, calculate the Q reaction. You will get Q reaction negative 8205.4 joule. Okay. Apa maksud Q reaction negatif 8205.4 joule? Ini adalah heat release when 0.1326 gram aluminium burnt. So, 0.1326 gram aluminium ini bersamaan dengan berapa mol? Kita kena kira mol. Kita kena tahu dululah kita terjemahkan dalam bentuk mol. Okay, tak cukup ni. Okay, jadi maksudnya kita kira mole of aluminium. So, you have to calculate the mole of aluminium. So, which is equals to 0.1326 gram divided by the molar mass of aluminium 27.0 gram per mole. So, bila you kira, you akan dapat lebih kurang 4.911 times 10 to the power of negative 3 mole. Okay, so yang 0.1326 tadi, gram tu adalah bersamaan dengan banyak ini. So, 4.911 darab 10 negatif 3 mol. 4.911 darab 10 kuasa negatif 3 mol ini, dia release sebanyak berapa? Itulah yang Q reaction tu. Jadi kat sini kita buat perkaitan matematik, stoichiometrical relationship. So 4.911 times 10 to the power of negative 3 mole releases. Okay, berapa banyak tadi? Tengok balik yang kita kira tu Q reaction. Ni Q reaction. Okay, releases negative. Okay, negative 8205.4 joule. But we are going to determine the heat release when 1 mole of aluminium burn. Therefore, if 1 mole of aluminium burn releases, okay, tunjukkan operasi awak kira. Okay, macam mana? Maksudnya, kat sini, 1 mole, okay, nak tulis 1 mole aluminium pun boleh, tak ada masalah. Okey, saya tak nak mol. Saya nak cari dulu. Maksudnya kat sini saya nak cari kalau negatif 8205.4 joule ni tadi released by how many mole? 4.99 times 10 to the power of negative 3 mole. So you kira dulu, you dapatkan dulu nilai. So you akan dapat dekat sini, you akan dapat lebih kurang negatif 1677.820.6 joule. Tapi sebab soalan dah mention kan, dalam soalan tu dia ada mention in kilojoule per mole. So you tukar dulu kepada kilojoule. Maksudnya ini sama dengan negatif 1670. Negatif 1670.82 kilojoule. So apa yang kita kira ni sekarang, actually this is the enthalpy of combustion. Jadi, apakah unitnya kat sini? Kilojoule per mole. Nampak? Okey? So, kalau you tak tulis per mole dekat delta H bawah ni, salah lah. Okey? Okey, jadi semua ni kena tunjukkan jalan kerja ni, stoichiometrical relationship, penggantian, sampailah jawapan akhir with the correct unit if any. Okay, so itu saja for second hour. Thank you class.